Hi, in this video, we'll be discussing important information on an introduction to protocols focusing on principles of DMX 512 for Martin Lighting. DMX 512 is a standard for digital communication networks that is commonly used to control stage lighting and effects. It was originally intended as a standardized method for controlling light dimmers, which prior to DMX 512 had employed various incompatible proprietary protocols. Each manufacturer had their own protocol and their own lighting controller that could be used to control their dimmers. DMX soon became the primary method for linking lighting controllers, such as lighting consoles, to dimmers, special effects devices like fog machines, and intelligent or automated lights. DMX's use also expanded to non-theatrical and architectural lighting environments at scales ranging from strings of Christmas lights to electronic billboards. DMX can now be used to control almost anything, reflecting its popularity in theaters and venues. Many light fixtures and other devices are capable of having their effects level of intensity adjusted. That level may range from 0 to 100%, where digitally, 0 is equivalent to off or no output, and 100 equals full output or on at the highest intensity. When communication is established between a lighting console and the fixtures or devices, numerical packets can be sent to each product via the data cable links by assigning an address, as well as a value for the level to accomplish a desired output effect. The fixture or device responds to an assigned address and knows to act on the level associated with that address. These numerical packets or values make up the DMX protocol. The industry standard consists of 512 channels per DMX universe, with each channel divided into 256 steps of resolution, or 8-bit protocol. 16-bit protocol can be used to gain higher resolution, similar to what's done with most color control, or anything that needs a finer control greater than 256 steps. DMX 512 employs an RS-485 differential signal as its physical layer, in conjunction with a variable-sized, packet-based protocol that is unidirectional, so it does not include automatic error checking and correction. If more than the maximum of 32 devices per chain are needed, then it's necessary to split the chain into multiples using what's referred to as a DMX splitter. In order to create spectacular light shows that you see at concerts or other venues, a lighting console is used to control all the fixtures. The console communicates with the products through the use of the DMX protocol. There are large varieties of lighting consoles on the market, so it's best to select one that suits your own production needs. Consoles can be very different, with a large number of features enabling you to do almost anything, including the same things, but in completely different ways from one another. Consoles typically have a control interface consisting of encoder wheels, buttons, sliders, and even touchscreens, while some are completely software-based with the use of a computer. The console is used to control different attributes of products like dimming, pan and tilt, changing colors and patterns, outputting smoke or haze, and more to create scenes or atmospheres. DMX 512 can be distributed by both a 3-pin or a 5-pin XLR cable. Since it only uses 3 of the pins, many devices have both 3 and 5-pin inputs and outputs in case you need to turn around the cables. 5-pin is the industry standard, and the only one listed inside the standard document provided by the Entertainment Services and Technology Association, or ESTA. ArtNet is a protocol developed by Artistic License, an actual manufacturer of lighting control boxes. They saw the need to surpass one universe per cable, so they came up with a way to open up multiple DMX universes over a single Cat5 cable. Given the restrictions on the IP range, ArtNet is a less flexible protocol. Standard Ethernet switches can be used to distribute data. In fact, the simpler the switch, the better, because managed network switches broadcast a tremendous amount of data. The pin conversion uses nodes, which are network inputs and physical DMX outputs, with active electronic devices in between to perform the conversion. The DMX system diagram consists of a console connecting to a fixture's input via DMX cable, and consecutive fixtures can be daisy-chained to one another via DMX outputs and inputs from the first fixture. Notice the addresses of each fixtures noted above them, which are set manually so there is communication from the console to the fixtures. An ArtNet system is similar to the DMX system, with the addition of an ArtNet node that connects to the console with a Cat5 cable. Then the fixtures connect to the node via DMX cables. Additional nodes, or even an Ethernet switch, can be connected through the secondary RJ45 jack on the initial node, where the ArtNet data is then sent to the fixtures. Some Martin fixtures have an Ethernet port that can accommodate direct connection of a node and accept ArtNet data directly. Streaming ACN is a protocol derived from the ACN protocol that was developed by ESTA as a response to concerns surrounding ArtNet in an attempt to provide a better protocol for sending a lot of lighting data over a network. SACN's streaming architecture for lighting control networks uses multicast, which reduces the data load on the Ethernet switches. Like ArtNet, data is sent over a single Cat5 cable. Unlike ArtNet, the IP addresses are not restricted to specific ranges. Using the priority capability, you can easily set which node is the main and the backup, giving the main the highest priority. In the event the main goes offline, the next priority will take over. RDM is a type of application that is added to the DMX512 protocol as a way of getting feedback information from lighting fixtures or devices by allowing the controller or console to poll those connected to it for lamp hours, temperatures, and sensor status. The implementation varies from manufacturer to manufacturer, which means some devices will work with each other, while others may not, since not all products support RDM. RDM traffic could be blocked by devices that don't support it, so cases like this could cause data network issues, as it tries to get that data in between the DMX packets. This could be problematic during a show, so always ensure that all products on the network support RDM if it is used. If a fixture is set to the same address as another, it will behave in exactly the same manner as the other fixture. At times, this is what is desired, but if individual control is desired, the addresses should be different. When setting up or addressing fixtures or device profiles, the capabilities in the DMX modes and the DMX maps provided by the fixture manufacturer can be set and controlled by the console based on the profile that gets created with information provided by the console manufacturer. This example of the Martin McAlor profile shows the DMX traits in basic mode. It notes the required DMX channels for operation. It also shows the maximum amount of McAlors operational on one universe, which is typically never enough. This is a good example of why controllers have multiple DMX universes to support hundreds of devices. A typical lighting console patch would look like this image. It would show that each fixture has an ID number, which you use to call up the lighting console to talk to the specific fixture, along with a unique address specified for each fixture's control channel. All of this information has to be manually entered in the console and the fixture or device for communication and control. The Martin P3 system controllers offer an easy-to-use solution to map video onto Martin Creative LED and lighting fixtures, including manipulation of the video such as scaling, rotating, mirroring, and more. On top of sending video to these fixtures, the P3 system controllers also merge in controls from any lighting console via DMX and ArtNet, allowing you to mix and match video and lighting control of the fixtures for the best of both worlds and more creative freedom. All connected fixtures are addressed, patched, and configured very easily. The communication between fixtures and a P3 system controller is fully bidirectional, so real-time feedback and error reporting enables you to have a full overview of the entire system, even in fixed installations where the P3 system controller can be monitored via the internet. In this Martin P3 rental application diagram, the use of any manufacturer's console can be used in conjunction with the P3 and communicates via a DMX ArtNet interface. The entire range of Martin LED video products can be controlled to produce uniquely creative visual applications. This concludes this service training. Thanks for watching, and we'll see you in the next one.